All right, let's dive into something that's absolutely critical for anyone in the energy sector. We're talking about how a universal engineering code, a rulebook for everyone, has to play in the sandbox of a global giant. This is all about process piping, ASME B31.3, and the unique world of Saudi Aramco.
Okay, I want you to picture this. You're standing in a massive refinery. There's this incredible maze of pipes stretching as far as you can see. So, who makes the call? Who decides the exact thickness of every single one of those pipes? Or whether a weld is good enough to hold back immense pressure? These aren't small questions, right? The consequences are absolutely huge.
So the answer? Well, it's not just some guess. It's not arbitrary at all. It all starts with a code, a kind of foundational document. Think of it as the rule book for engineers, not just in one country, but all over the world.
And that foundation? It's called ASME B31.3. You've probably heard of it. It's the code for process piping put out by the American Society of Mechanical Engineers. This thing is the starting point for, well, pretty much everything. Design, materials, how you build it, how you test it. It's used on countless projects.
But, and this is the key takeaway, the whole reason we're talking about this, on a mega project, especially one in the Saudi Aramco ecosystem, just following B31.3, that's only the first step. It's just the beginning. The code, all by itself? Nope. It is absolutely not enough.
So this gets us to the real heart of the matter, right? We're talking about the difference between a foundation and a control layer. And trust me, you've got to understand both if you want to see the whole picture.
Okay, look at this. This really lays it all out. On one hand, you have ASME B31.3. That's your foundation. It gives you all the fundamental rules for piping design, the basic engineering principles. But then, on top of that, you have the Saudi Aramco standards. This is the control layer, and they add their own specific and, yeah, almost always stricter requirements right on top of the code. So you're probably wondering, how does this control layer actually work in the real world? Well, it all comes down to a power structure, a really clear hierarchy of control. And if you're an engineer on one of these projects, you absolutely need to get this. Let's break down how it's all structured.
Here it is. This is the whole system in one shot. Right at the very top, the king of the castle, you've got the SAES, the Saudi Aramco Engineering Standards. Then, underneath that, you have the ASME codes, like our friend B31.3. Below that, you get into the project-specific stuff, the specs and inspection and test plans. And at the bottom, there's the actual execution in the field. The big takeaway? It is 100% a top-down system. Aramco standards? They always, always come first.
And this right here, this is the golden rule. It's the enforcement mechanism that makes that whole hierarchy work. You'll find this line buried in most Aramco contracts, and it is non-negotiable. If the B31.3 code says one thing, but an Aramco standard says something stricter, guess what? The Aramco standard wins. No debate, every single time. All right, so that's the theory. But theory is one thing, right? What does this actually look like on the ground when you're trying to get a project built? Let's dig into a couple of really concrete examples so you can see the system in action.
This table is perfect. It shows exactly what we're talking about. Take corrosion allowance, for instance. B31.3 is kind of flexible. It lets engineers use their judgment. But Aramco's standard, SASL-110 in this case, often just slaps down a strict minimum, say 2 millimeters. That's it. End of story. And look at materials. A material could be perfectly acceptable according to B31.3's Appendix A, but if it's not on Aramco's own approved list, the SAMS, the Saudi Aramco Materials System Specification, then you just can't use it, period. So if you're going to remember one thing, remember this. B31.3, that gives you the engineering formula. It's the how-to for calculating stuff like pipe thickness. But the SAS, that enforces corporate policy. It's all about making sure there's standardization, top-tier safety, and longevity across every single one of their massive facilities. It's really the difference between a calculation and a command.
Okay, so why does any of this matter? Why have we spent all this time digging into it? Because, look, understanding this whole dynamic, this isn't just some academic exercise. This has huge real-world implications for your career and how effective you are on a project. I mean, if you're a QC inspector, a piping engineer, a stress engineer, heck, even a planning engineer or a project manager, this is absolutely need-to-know stuff. Seriously. Knowing only the B31.3 code is like showing up to a football game knowing only half the rulebook. To be truly effective, you have to understand the entire system. And really, this is what it all boils down to. Look, lots of people can read and apply the B31.3 code. That's a given. But the number of people who can truly navigate how it connects to the SASs, the SAMSs, and that whole complicated project approval workflow, that number is much, much smaller. And that deeper understanding, that is literally the difference between technician-level knowledge and real professional mastery. It's a game changer.
So I want to leave you with this question. What we've talked about here, ASME and Aramco, that's just one example. But every industry, every major client, every big company has its own version of this. They all have their own control layers on top of the standard codes. So think about it. What are the control layers and the hidden hierarchies that govern your work? Because figuring that out, that's the key to unlocking your next level.